I'm going to talk about ethics by design, which is our attempt to make take the development of artificial intelligence systems from being aspirational in terms of their ethics into a concrete, if you like, an engineering process. So the basic idea is that you start with a set of values. Values lead to norms, which lead to things that you should do. So in a general sense, there's a relationship between values and the behavior. What we've created is a system by which we've taken values, we've turned them into requirements. That's something that a technology must do if it is going to embody the norms and the values that we've laid down. So this is not just in terms of what the machinery, if you like, or the technology should be able to do, its features, its functions, but it also affects the way in which it's used. And one of the things that's become apparent is that how you actually build a piece of technology can have a dramatic impact on its ethical outcomes. So this has been recognized widely in the software development community. It's now known as the values by design approach. It started with privacy by design in Canada, but it's generally grown. And there's a general recognition now that the best way to embody the values that you wish in a technology is to think about those from the very beginning of the process. The days are over when you can say, well, ethics is something after I've created the project, I'm just an engineer, it's nothing to do with me. What we've realized is that in actual fact, it is very much to do with the development of the system to a large degree. So what we've done, as Philip mentioned, is we've taken values which we consider to be relatively uncontroversial. They're as universal as possible. They're ones that have been under a lot of development for a period of time. And then what we've done is ask ourselves, if we want to build AI systems that embody or support these values, or at the very least fail to violate these values, what does a system have to be like? We call those requisites. So they are similar. We've avoided using the word requirement, but intentionally, because it leads to other aspects of software development and so on. But basically what we're saying is, when you're thinking about building a system, these are the characteristics of the system that you need to build into it. In the same way as somebody needs to think about reliability when they're building a product, they also now need to think about these ethical requisites. And what we're trying to do is very much bring them down out of the abstract into something very, very concrete, which any engineer can follow. So requisites, the characteristics of a system, lead to what we call ethics by design guidelines. So these are specific tasks which must be done during the creation of the system in order to create a system which embodies these ethical requisites. So Philip's gone over these briefly, but just as some examples, we've talked about things like the requirement that an artificial intelligence give humans as much control as possible, that they don't try to create dependency. So the value here is a respect for human agency, things like autonomy, dignity, and freedom. The requisites that an AI system should embody are then things like it should give people control. With data, obviously, it's going to have to be compliant with the GDPR. And one of the things that we're very keen on, because data bias is so much of a problem in the ethics of AI, is our requisite is you assume all data is biased until you have proven otherwise. In terms of well-being, we've covered individual well-being, social well-being, and particularly in the case of robotics with materials and so on, the impact on the environment. And throughout the whole ethics by design process, there's a very, very strong emphasis on as much transparency as is possible. There's an assumption, and it's often an assertion within AI circles, that it's not possible to understand what is going on inside the AI. We believe that in many cases It could be a lot more possible if the systems were developed in certain ways, if documentation was created either by the engineers or by the system itself as it did things. And then, of course, we have many mechanisms in the world today for testing the safety or the compliance of products without needing to open them up. What is known as black box testing. You can treat the product as a black box, but you can still evaluate it and so on. And fundamental to all of this is the belief that those who build and operate the AI are responsible for its effects. You can't simply say, think because this thing makes its own decisions, nobody is responsible. And obviously, if we're going to identify AI systems that are problematic, we need to be able to change their behavior to remove it. This is well recognized in the industry. Explainable AI is an entire system of software and methodologies and so on, specifically to make artificial intelligence explainable to humans. In order to do this, in order to apply these values and requisites to a system, and in order to convert those into concrete tasks that we can ask a developer to perform, we need some form of model of the development process. And there are lots of different models in software engineering. There's things like Agile and V-model and so on. So what we needed was a generic development model that could then be applicable to whatever methodology a particular institute or developer was using. So we call this the generic development model. It's provided as a list, but it doesn't have to be done sequentially. It's really a list of the types of activities that somebody has to do in order to build a system. So to start with, obviously, you have to start with deciding what it is that the thing's going to do. You then need to work out, if you like, a project plan around what it is that's going to be required to build this. And we're talking about processes, tools, staff, organization structures. And at that stage, you will often start to specify some things peripheral to the system that you need in order to test it or construct it and so on. There is a process of high-level architecture. This is where you say things at a simplistic level like, well, we need a unit that brings data in, and we need another component that's going to process that data. We need another component that can implement the decisions of that data. We need a system for taking in an interface for taking information from people and so on. Obviously, artificial intelligence works with data, so there's a major aspect of the work is data collection and preparation, and then there's a detailed design and development process, and often that is going on in parallel with data collection and so on, which is when you're sitting down to construct the system, and finally, you have a testing and evaluation stage. And so what we've done is for each of these phases, we've taken the requisites from the values and worked out what it is you have to do at each of these phases relative to each of these values in order to build the system. So the format is very much for each phase, you have a number of requisites. For each requisite, you have a number of specific tasks that you're asked to do. So what I just want to quickly do is just give you an example. And I thought what I'd do is I just pick one value, which is fairness, and give you examples of specific tasks that are required to achieve the requisites for fairness at each of the phases. And this is by no means an exhaustive list. This is simply a sample of tracing different ways in which fairness is embodied in particular tasks. So, for example, when you're designing your system, the first question to ask regarding fairness is whether, if it does what it is you want it to do, is that going to result in stigmatization of particular groups, particular subsets of society and so on? Because obviously, if that's what's going to result out of the product, you've already got an ethical issue before you go any further. And then you're going to need to, when you're designing the project structure itself, you're going to need to put in place procedures for assessing and correcting for bias, and not just procedures, but you need structures to make sure that, for example, the person who detects bias and whose responsibility it is to see that it's fixed has the power in the organization to ensure that it is fixed. And so there's always a cross relationship between procedures, organizational structures, and tools in all of these phases. Once you start the higher level design, you're going to start designing your interface. You should run an accessibility test to make sure that the interface meets the standard accessibility standards. It copes with disabled people in various ways and so on. And this is a fairly standard requirement of most software these days. Once you come to collect the data, what we know is that as well as bias being within data, sometimes the problem is inappropriate data was selected. Sometimes too much data is selected, or the data that's selected doesn't match the purpose for which it's going to be used. So one of the things we're saying is document the reasons that you used to determine what data would be selected. Don't just tell us what data you selected. Don't just tell us the reasons why you selected that data. Tell us what it was you thought you were going to do, because this will support, as well as ensuring a fair system, this is going to support things like transparency. If we're concerned with the data bias, we're going to want to know how it was that you acquired this biased data, and what can be done in the future to address that. Once we come down to the detailed design phase, we accept that perfectly good data can become biased during the machine learning phase, possibly because of the design of the machine algorithms, but we also have things like data drift, data loss, and so on. So the detailed design phase requires regular checks. Every time the data moves from one phase of the system to the next, you need to have in place a check to make sure that you aren't accidentally developing biased data within the process. And then finally, one of the ways of testing for fairness when you come to finish your product is to literally test the system's decisions on if it's affecting people on minority groups. This is particularly important, for example, in facial recognition. We know that facial systems often are less effective on people with darker skin than with pale skin. So we would ask that those sorts of things are tested for as part of the testing regime. So that's it in a very brief nutshell. As I've said, this is not an exhaustive list. We've got over 60 specific tasks that we've tied to this. I think the key thing before I finish off is to understand that the generic development model is not prescriptive. It's designed as a high-level model to which we have tied the tasks, which makes it very easy for somebody with a concrete methodology that they are using, like, say, Agile or V model, to say, okay, my equivalent phase of that is this, therefore I can plug these tasks in there and so on. So what we've really tried to do is, if you like, take the philosophical thinking out of the whole process and just say, okay, guys, these are the things you need to do in concrete terms.